Hi, I'm Professor Seth Chandler from the University of Houston Law Center, and this is a lecture on classification and proxy discrimination. Let's start by creating some data that we can use. The first is going to have 3 columns. That's all. The first column is something measurable like income, where a high value is better. The second column will be race, which for simplicity will be a binary in which 0 means a member of the majority and 1 means a member of the minority. And the third column is performance on something we care about, like a test or performance in law school or success on the job. And 0 is failure and 1 is success. Now I'm going to construct the data using something called a Copula distribution. You don't need to know what that is, except that it permits you to create complex interrelated distributions out of simpler distributions. But the key thing is actually that 0 right there and the symmetric 0 right there. What I'm going to do is I'm going to say that high income and positive race, which means minority status, are negatively correlated, but high income and performance are positively correlated. And after you take income into account, race and performance have no correlation whatsoever. These things are simply, we're going to have income be normally distributed, a bell curve. We're going to have 20% of our population be minority, and we're going to have 70% of them succeed. So we're just going to create a copula, and we'll then create 5,000 sample people on which to train our machine learning algorithms, and then we'll test it on 5,000 people that the machine has never seen before to see how well it performs. All right, so we can actually see what the distribution of income looks like for our majority and minority groups. And what we can see is that for minorities, while there are plenty of them that have decent income, there aren't too many actually that have very, very high incomes. And similarly, for majority members, there's a lot of overlap, but when you sort of get to the extremes, it looks like it's mostly minority. All right, so what else could we do? We can see the correlation between race and success on the test. And we're going to see that there is a somewhat of a correlation. That is, this is like 2.5 times higher for the majority and just a little over 2 times higher for the minority. So this is not where all the minorities are failing the test or anything like that. It's just a little lower statistically, although there's no causation here. The causation structure is set up here, and it's saying that there is no causation between race and score. The only thing that makes it appear that way is that there is a correlation between race and performance, race and income, or whatever you want to call this first variable, and income and ultimate performance on some job or test. All right, so let's now try to use machine learning to come up with an algorithm that's going to predict success on the test. And I'm going to use a fancy algorithm, a modern algorithm called gradient boosted trees. So we'll run that, and then we'll see how our classifier performs on data that it's never seen before. So what do we see? We see that it's 81% accurate in making classifications. Here's how it breaks down among actual class and predicted class. So this is telling us that 620 people who were actually going to fail the exam are predicted to succeed or succeed on the job. And for example, this tells us that of people who actually would succeed on the job, 347 of them were classified as not likely to succeed. So our false positive rate is about 40%. Those are the people who aren't going to succeed, but our classifier thinks that they will. And our true positive rate is about 90%. Those are people who will succeed, and our classifier has correctly predicted that. The overall positive rate is about 74%. That's that 3717 figure divided by the 5,000 in the whole group. All right, so that's the overall performance of the classifier, but let's see how it does on different groups. Let's see how it does on minorities, for example. And what we see is that the overall accuracy is about the same, 80.967%. That's, probably one person different than it was for the overall group. But the positive rate is 67% as opposed to 74%. And if we look at people who won't succeed, or don't succeed, we're saying 28% of them will. So these are sort of the undeserving who might be admitted, and 85% of those who will succeed we're correctly predicting. So not terrible, but let's look at how it does on the majority. And what we'll see is accuracy is, within one person on both groups, but the positive rate is higher. And why is that? It's because the machine is going to let in 42% of undeserving majorities, and it will admit 91% of deserving majorities. And so both the false positive rate and the true positive rate are higher for the majorities than for the minorities. And many people would say that's unfair. You should have it so that if someone's going to succeed, the classifier is equally likely to predict that regardless of race. We can have a little better view as to what's going on by looking at something called the ROC curves for both majorities and minorities. These are sort of advanced diagnostics to look at how a classifier is performing, and it is taking a moment to develop that. Okay, let's take a look. If we look at these curves, the curve for the minorities and the curve for the majorities, they are just about identical. What isn't identical is the location of the dot. This is where this classifier is sort of actually coming out, and you can see that there's a lower false positive rate and a lower true positive rate. We call it the same thing as true positive for minorities, and for the majorities it's somewhat higher on false positive and somewhat higher on true positive, which is exactly what we found before. But if this is a measure of how well the classifier is doing overall, there's no difference. It's just that sort of the choices the classifier is making is different. So many people would regard that as quite distressing, and maybe it's the fault of modern machine learning. Maybe if we used something simpler, we wouldn't get that. So I'm going to use a very simple classifier, something called a decision stump. And this could have been done 100 years ago, basically, where you just try and make a very simple decision tree on whether you're going to admit someone or not. So we'll build that, and then we'll see how it performs overall. And we can see overall it's not as accurate, and the positive rate is actually quite low. It's a little distressing because it's screwing up. It's only letting 50% in, whereas in fact, whatever it was we said, 3/4 of the people succeed, or 70% of the people succeed. So again, let's see though how it does differentially. That's our main concern here, is how the classifier performs on our different racial groups. And we can see it is being, this is like yick woe. It's basically, we're almost not letting anybody in who is a member of the minority. The false positive rate, we're not letting anybody, only 2 people who were unqualified in. And even among those who were qualified, the machine is being very hostile. So let's see about majority members. And for the majority, it's a happier picture. It is letting in some unqualified members, the son of the prestigious financier who gave a lot of money to the school but is really dumb. For those who would be successful, it is letting a fair fraction of them in. So it looks like actually minorities did better when the classifier was more sophisticated. So far, I've let our classifier take race into account in making classifications, but we might well regard that as abhorrent, or it's a focus on stuff that's irrelevant, or it's an invitation to discriminate. And yes, it does facilitate discrimination against minorities if that's desired, but maybe it also creates issues for the honest classifier because now there's no ability to disentangle income from race. So let's see what happens when I withhold information from the classifier on race. And what we see is the accuracy is a little less than it was before, and we've got an overall positive rate that, let's actually look and compare, 74.48% to 74. All right, so it doesn't make any difference in the overall, overall classification positive rate. But now let's look at how it does on minorities and majorities again. And for minorities, our classifier is still not very enthusiastic. The overall positive rate is only 48%, and we have, of those who really would succeed, we're only letting 64% of them in. The accuracy is about 72%. Let's see how it does on majorities. On majorities, it's more accurate. It has a higher positive rate, and we're letting a substantial fraction of the unqualified in, and a very high fraction of those who are positive in. And so again, I would say that in this instance, withholding information from the classifier about race is doing minorities no favors because it is impairing the ability of the classifier to disentangle income from race, even when race is actually irrelevant to performance. So to summarize, we can actually look at the overall stats for each of our classifiers, and we can just compare here, and we can see that the classifier tends to have better statistics, it's more favorably disposed towards majorities than it is minorities, and that finding essentially persists regardless of whether the classifier is blind, shallow, deep, etc. So there's a lot more to be learned from this experiment and a lot more variations that we can do, but I hope this gives you some idea as to the subtleties of doing classification, which is what we really need to do all the time, when we have various factors that are entangled with each other, and often what might seem intuitive turns out not to be true.